Okay, I'm Justin Moon.
I'm Matthias de Bernardini.
I'm Suhail Sakan.
I'm Cody.
And I'm Christian.
I'm Mark Goodwin.
Seth Thomas Meyer.
And our project is called MiniSimp. It's gone through many iterations, but this is what we're currently calling it. If you attended my talk during BTC++, I talked about Fedimint, which is kind of the idea. MiniMint is the first implementation of the idea. You might have heard about it as a Chaumian bank, but it's really more than that. It's like a federated framework for building. It's a framework for building federated financial applications on top of Bitcoin. And so when you're building such an application, you end up writing contracts. And this is what they look like currently. It's a big bunch of Rust code. We write it all custom. And this is really what, for example, Bitcoin script is for. You know, it's a common abstraction to write contracts like this. But Bitcoin script kind of sucks, right? Can we all, maybe Barack would disagree, but everyone else probably doesn't like writing Bitcoin script themselves. But Christian, do you know of anything that improves on Bitcoin script?
Maybe simplicity. So simplicity is a language that is developed by Russell O'Connor and me at Blockstream. And it's a language that we can use to express spending conditions in a declarative way instead of relying on a C++ implementation. And this project is actually the very first deployment of simplicity ever. So the first application of simplicity to a practical problem. So this is really exciting.
So that's what we did. We took the MiniMint source code and hacked in simplicity, and we implemented one contract. It's a script hash lock, and it's executed inside. It's a simplicity program, and it's basically kind of pay to script hash, but instead of a Bitcoin script, it's a simplicity program. So do you want to kind of describe what a simplicity, or I mean,
yeah. I mean, I think we can all agree this is kind of obvious. What's going on? It's the cursor, right? So, oh, sorry. Maybe you can see the cursor. Thank you. So we take a witness, and this is the image, the pre-image that the user provides, and we hash that using SHA-256. We use scribe, which hard codes the image that we commit to. And then we compare if the hashed pre-image that the user provided in the witness equals the image that we committed to in the transaction output.
Cool. So this is what it looks like. For every output, we get one of these, basically an ID for one of these simplicity programs called commitment Merkle root.
Exactly.
And then when you spend, you have to supply the witness, right, which is the program. Or you supply the program and then the witness, which is the pre-image. So it's kind of like pay to script hash, where this would be the script hash, but instead it's a commitment Merkle root. And then you end up with the same thing. And so let me hop out of this, and you can go to my GitHub if you want to see what we did. We wrote 600 lines of
name.
Yeah. Simpiment. Yeah, it's the name changes. So hop over to the code here. We wrote one unit test. That's what we did. So we create a spendable output that is one of these hash lock contracts. It's locked with a pre-image of all zeros. We try to spend it with a bad pre-image, which is ones. This is an error. We reclaim it with a correct pre-image, and it works. We unwrap it if you know Rust, and then we try to double spend, and that fails. And so the core in the code, MiniMint has a module system, and every module implements validate input. If you look over here, we have 3 modules currently: an on-chain wallet, on-chain wallet, Chaumian Mint, and Lightning. So we just added a simplicity module. And so yeah, when we validate this input, we check if the amount is right. We check if the program matches what the hash of the Merkle root. The hash of the program, or the Merkle root of the program, matches the one that we committed to earlier. And then we just toss it inside simplicity and execute it.
On Simplicity's bit machine.
Yeah, on Simplicity's bit machine. And if you remember, this is basically that graph we showed in code. And just to show that it works, I'm going to run a unit test. It passes. All done. So yeah, that's our program. I mean, so we learned some interesting things. We found a simplicity bug.
Yeah.
So this is one of the interesting things about using one of these research projects is oftentimes they're not used, and maybe the computation of a hash won't work. If you're interested, follow us on Telegram. Follow us on yeah. Check out the MiniSimp GitHub repository and Simplicity GitHub repository for the Telegram links.